Hey everybody, it's Mr. Zand, and I'm going to talk to you about molarity. Now, molarity is kind of a topic that I like to throw in at the very end here because it brings together all sorts of other ideas that we've been talking about throughout the year. One of them is moles, one of them is concentration, and others, you're working with these solutions all the time and these chemicals all the time. So it's a way of describing how much of the chemical is in a given kind of amount of volume. So it's really describing concentration. So molarity, there's lots of ways of describing concentration. I'll start off with that. There's something called molarity. There's something called molality, and there's also something called percent mass. Okay. We don't really care about these things. Molality and molarity. I could describe them right now, but it really doesn't matter, and it might just confuse you. So I'm just going to describe what molarity means. It means the moles of solute per the liters of solvent. The moles of solute divided by the liters of solvent. So if you think about that, let's just give an example real quickly here. If you think about this, if you've got, let's say, I don't know, 5 moles of salt, NaCl, in 1 liter of water. Oftentimes, water is the solvent. It's almost always the solvent. We just often just say liters. We don't even say it's water. We just assume it's water. Um, compare that. Compare that versus 15 moles of NaCl in 1 liter of water. Okay. So, which one of these is more concentrated? I mean, it should be obvious here. The 15 one, yes, there are more of these NaCl atoms dissolved in this water than there are over here. There's just less over here than there are over here. So when we talk about moles, we're really talking about, so it's the 15 times, it's really 15 times 6.022 times 10 to the 23rd. Okay. These aren't really molecules, but they're pairings, I guess. They're like ionic bonds. So that's how many of these NaCl's, I'll just say that, we have. Compared over here, just 5 times 6.022 times 10 to the 23rd. So it's less over here, times 10 to the 23rd of NaCl, dissolved in 1 liter. Now, this one's less than that, so this one's going to be more concentrated. That's a way of measuring concentration. Way of measuring concentration. Another way of measuring concentration is a test. If you aren't concentrated, then you won't remember anything and you'll do badly on a test. Joke. Okay, so next we are going to go through some ways of manipulating this equation. So some simple way is just like a simple kind of question I can ask you is if I give you molarity and I give you liters of solvent, you need to find moles of solvent. So we're just using this equation up here, that equation up here, and I'm giving you 2 out of the 3 variables up here. So I'll give you like moles and liters, and I say, what's the molarity? Or I'll give you molarity and moles, and I say, how many liters is that? Or I'll give you liters and molarity, and I say, how many moles are in there? Those are kinds of questions I can ask you. So it's really just manipulating an equation that looks like this. We got moles over liters. I just made this shorter. I abbreviated it. And you can just rearrange this with algebra. I hope you can do the algebra for this. I really, really hope so. Really, really hope so. Let's say you want to find moles. It'll be M times L equal moles. Let's say you want to find liters in this case. Ooh, we had to multiply both sides by L and then divide by M. So if you want to find liters, it's going to be moles divided by big M. Convince yourself of that. If you want to find moles all by itself, you just find, so moles will equal molarity times, oh, I already did that up there. If you want to find, obviously, if you want to find molarity, it's just moles divided by liters. It's already given to you. So those are the three ways this equation can be written. Okay, big deal. I'll just give you some. So I guess like the hardest thing about this is just sometimes I don't give you moles. Sometimes I'll give you grams of something. How do you go from grams into moles? How do we do that? So I'm just sketching the kind of like skeleton of how to solve these kinds of problems here. So if I give you a problem where you have grams and you need to find the molarity, and you know the liters, well then you know how to get from grams to moles, and then you know how many liters there are if it's given to you, so you can find the molarity. So the little wrinkle in these kinds of problems is just saying, okay, I want to use grams with these equations over here. So how do you go from grams into moles? Again, so grams of anything, so let's just grams times the molar mass of whatever it is, 1 mole over the molar mass in grams will give you moles. And vice versa, if you want to go the other way around, if you want to go from moles back into grams, you take the moles, and you set up this little conversion factor over here, you put the 1 mole down below, and you put the molar mass of whatever you're talking about up above, and then I'll give you grams. Okay? So that's how you go from grams to moles and moles to grams. So those are easy conversions. And just in case you don't know, molar mass is the thing you look up on the periodic table. Okay, it's that, 12.011 grams, just in case you've lost or you've hit your head or something. Okay, great. The only other kind of question I can ask you is something like a dilution question. So these are questions where you're talking about molarity, and you're talking about grams, and you're talking about liters. If you ever have to dilute something, so these are dilution questions. Dilution questions. I'm going to give you an equation that will help you. It will be so easy to answer any of these problems if ever you see something like diluted, or ever like your liters are added to, or the volume changes, or anything like that. A dilution, I'll just define it first of all. A dilution is when you take something that's concentrated and you add more solvent to it. Okay, so you can think about like mixing a bunch of Gatorade together, or iced tea, or whatever you make. If you add more water to it, it'll become more diluted. You can do the reverse. You can concentrate something if you've got something like a filter that just takes out the solvent. Or you can just leave it outside and it will evaporate. The solvent will evaporate before the solute. So it will make it more concentrated. I don't know if you've ever done that, but a fun experiment to do, not with anything you care about, but a fun experiment to do is to put like soda out on a sunny day and just let it sit in a container, and then come back at the end of the day and see the sludge that is left. The sludge is just the solute, which is mostly sugar, actually, in soda water. And the water has then evaporated. So you have this sticky, syrupy kind of thing, which might be, now I'm thinking about it, that might be a really nice way of making like Pepsi syrup. If ever you want to make Pepsi syrup, there you go. Just lay it out in the sun in a container, and then you'll come back in a couple hours, and you'll find a nice, sticky, thick Pepsi syrup. Anyway, let's go back to dilution. So dilution, if you look at this equation right here, which I love, one of my favorites in this class, it's Mao Lao equals Min Lin. Mo Lo equals Min Lin. The O stands for old. The N, in both of these, so both old, stands for new. That's old as well. Now, what do I mean by this? This is the molarity of the old solution times the molarity, times the liters of the old solution will equal the molarity of the new solution times the liters of the new solution. This is assuming you don't lose any of your solute. Okay, that's a big assumption here, but in all these problems, that's all we do. We just keep the solute, and we're either increasing the amount of solvent or we're decreasing the amount of solvent. So let's give you a quick example of this one, because this one is easier to see with an example. Let's say you've got a 5 molar solution of something, and you've got it dissolved in 2 liters. Okay? Then what you do, you silly person, you add more liters to it. So you add an extra 3 liters to it. So instead of 2 liters now, the new amount of liters will be 5 liters. And the questions always ask, what's the new concentration, or what's the new molarity of this solution? So I've just set it up in this kind of equation right here, where you don't know what the molarity is of the new solution. So I'll just put in Mn, because I've substituted already the MO, that's the old molarity, and the liters of the old solution. I don't know what the molarity of the new solution is, and I do know what the liters of the new solution is. R, whatever. Okay, so to find this, it's pretty obvious what you got to do. You got to just rearrange this so that you divide these by 5. Whoa, I can't go down any further. Divide by 5. Divide by 5. So this is going to be, our molarity of the new solution is obviously going to be 2 molar. Okay, so that's how you do that. How am I doing on time? I'm going to take a quick break, and then I'm going to put the next video up with an example problem, a set of warm-up problems. Okay.